Hello, my dear friends. Welcome back. Those who have been following me regularly and have done all the numericals posted so far. If not, go back and look for the numericals that you want to and wait for the other numericals which will be posted subsequently. This is SK Booty here, Booty Aviation Training channel and on YouTube, and continuing with my next lesson in navigation numericals. And today's lesson is about a very interesting topic, often asked in the examination, CPL, ATPL, and even in airlines. What is a critical point and how to calculate it? And let me tell you right in the beginning, it is very simple. If not till now, you'll find it simple after the end of this lesson. Okay. What is a critical point? What is so critical about this point? It is that point on track from where it takes equal time for a pilot to either return to the home base, that is called the departure point or home, or proceed to the destination. Okay. So you are heading from departure to the destination. And let's take an awkward case. There is food poisoning. And now I have to take a quick decision without wasting any time. I should have done these calculations on the ground, which we are going to learn now, where you can take an instantaneous decision. Whether should I continue or return home? Well, of course, if there is another airfield available, that is your diversionary aerodrome is available nearby, by all means. Today we are dealing with a topic where you have no choice. You either have to return to departure or continue to your destination. Okay, London to New York. It's all ocean, Atlantic. What do? I either return to London or continue to New York. I'm stuck halfway through. And if I have no diversion, suitable diversion for my aeroplane, that point from where it takes equal time to home or to continue to destination is called critical point, equitime point, ETP, or point of equitime. And this point lies on your track, for which we should know what is our total distance. What is my ground speed outbound? We'll call it O. And if the distance is in nautical miles, ground speed will be in knots. And in case I have to return home on my reciprocal track, what ground speed will I get? Remember, if it's headwind on outbound, it will become tailwind on return. So calculate the values of O and H and D I already know. Now, a little bit of theory. If a pilot decides to return home by this distance X to the critical point called DCP, with the ground speed home, distance by ground speed is time, should be same as remaining distance D minus X divided by ground speed outbound with which he was flying. These two times should be equal. O and H is not known to me. X is the only part not known to me. X called DCP, distance from the departure to this point, DCP, will be DH over O plus H. I will calculate this point on the ground. I know I've done my flight training. And time to the critical point will be this distance X divided with my ground speed outbound with which I was flying. And let's say I have calculated as time as 1430 UTC. In case of an emergency, just look at your watch. If this point has passed, carry on. If not, return home. And you will be taking the least time out of these two. If exactly at this point, you have a choice. Okay? Then find out where will you get better facilities. Now, supposing your examiner tells you that you are going over this ocean from A to B, etc. Calculate that point from where it will take equal time to carry on or return home in case you have an engine emergency. What is the difference? Now, in an emergency, my speeds will become less. I have lost an engine and I'm on now partial power. So therefore, now my true airspeed will fall and so will the values of O and H. Now for calculating the value of X distance to critical point, use O and H with reduced power, ground speeds, which I'll get on my reduced power, and calculate this point X and divide it by my normal ground speed outbound, not with the reduced. Here I have taken both reduced. Normal ground speed outbound, I'm flying with my normal ground speed. I just want to know, have I crossed this point or not? Okay. If the time is gone, carry on. If not, return back. If you are exactly over this point and the engine fails, both sides, you will take equal time. Next. For an example, place A to B, total distance 900, true airspeed 250, and there is a headwind of 25 knots on the outbound, and find the DCP and TCP on normal and reduce power if due to engine emergency, my TS reduces to 200. That you will know from your aircraft manual. D 900 O 225, 250 less 25 on outbound. Home will be 250 plus 25 on return. And my DCP will be 495 nautical miles. This 495 divided by ground speed outbound will give me the time at which, or the time that I will require to cross this point, and to your departure time. If you add this time, you will get the ETA over this place, estimated time of arrival. Just note it down. You don't have to note down the entire summary. Just note down that time with you, okay? And just look at the time when there's a problem and you will know, have you crossed it or not? In case of reduced power, my true airspeed is 200. So my ground speed outbound will be 200 less the wind component. It will be 175. On return, it will be 225. Now, same distance into reduced ONH values. My DCP on reduced power is 506 nautical miles from my departure. And while I'm now on my normal flying, calculate the time required to reach this place. This distance divided by my normal ground speed outbound, that is 225, with which I am flying. Don't use the reduced value of O because I've been flying at my normal speed. I just want to know, have I crossed this point or not? Now, there is one more method of finding out the critical point, and some people find that more convenient. Okay, let's do that also. Now, please understand the concept. This is departure and destination. Total distance is capital D. Halfway point will be D by 2. This total distance is 1200 divided by 2. 600 nautical miles. You're under normal conditions, nil wind conditions. Okay. And your point will lie midway at D by 2. But in case there is a wind velocity okay, this point will shift. In the case of headwind, winds coming from the front headwind, that is these winds, or from this side, your point will shift towards head. Under headwind conditions, it will shift towards head. Your distance to critical point will become more. Why so? Because on going out, I have a headwind, but on my way, my ground speed will be more. It will be a tailwind. So the time will be equal. Under tailwind conditions, you must turn earlier because coming back, you will have headwind. So under tailwind condition, the point will shift towards your tail, and your tail is your departure point. So when the point shifts towards your tail, distance dCp becomes less, which is always measured from departure. If it shifts towards a destination, dCp will become more. How much will it shift from the midway point? D by 2, that is half the distance, multiplied by wind component by TAS, that is the average of the headwind and tailwind component. Now, if you calculate with the help of nav calculator and apply the wind velocity, if the winds are coming from the front, let us say this is your track and winds are coming from the front. On the outbound, you will have a headwind, and on the return, you will have tailwind. On the outbound, ground speed will become less. On the return, it will become more. So, but please remember, it will not be equal. The penalty given by the headwind is always more than the advantage given by the tailwind when you are flying. Try it out. Take a track of 045, wind velocity of 120. Now it is 75 degrees from the right and front. 120 and 30 knots. This is your track. And take a true speed of 200. On the outbound, speed will be less. Find out how much less. That is called headwind component. On the return, your ground speed will be more. How much more? That is called tailwind component. So you'll find headwind will be equal to tailwind, or the headwind will component. The reduction in your speed will always be more than the tailwind component. Theory question. Okay. Now let's get back to where we were. If the component is given to you, that is a average component. Let's say there's a tailwind component of 30 knots. That means on the outbound, speed will increase by 30 knots, and on the return, your speed will decrease by 30 knots. If tailwind on the outbound, there'll be headwind on the return. So to find out, first check up what is the wind component. Find out how much will it shift. D by 2 into wind component by TS will be the number of nautical miles your point will shift under headwind conditions towards head, under tailwind conditions towards tail. Let's take the same question which we had done in the last slide. Distance was 900 nautical miles. There was a headwind component of 25 knots and true air speed was 250. So D by 2, 450 into wind component by TS is 45 nautical miles. Now my critical point will shift 45 nautical miles towards head. So it means from departure, it will be 450 plus 45 is equal to 495. See the last question. Did you get the same answer? So there are two methods of doing this. Now let's say a question, sometimes they ask you in the examination, total distance is 800 nautical miles. If dCp in tailwind condition is 350, what will be the dCp in headwind conditions? Now you are looking for values O and H, nothing, how to calculate, not required. Total distance is 800. In nil wind conditions, your DCP will be 400 nautical miles from departure. Under tailwind conditions, it has shifted 50 nautical miles towards your tail, and DCP is 350 nautical miles. In headwind conditions, it will shift 50 towards the head, and your answer will be 450. Very often asked question and very simple, and people keep struggling that which formula should I use, dH over O plus H or this formula. So you are using the concept in this particular case. Good, well done. And I'm not going into the theory in this lesson that if headwind increases, what will happen to CP, tailwind increases, or if the TS changes, that I will be covering in theory lessons. Right now, we are doing the numericals in this series. And let me give you a few numericals for your practice. As usual, copy down these numericals, do these numericals, and then look at the answers, which I will give you in the next slide. Don't cheat yourself. Don't try to look at the answers for each question wise. Take some time, do these questions together, and come back to this lesson and go to the next slide. And you will get your answers, which I'll give you in a short time. Well, question number 1 and 2 require no hint. Question number 3. This is your track and the TS and the wind velocity. And he wants a critical point in case of an engine failure with the reduced power. Okay. Try it once again. I hope you will get your answer. If you have understood what I told you in the last lesson. Next is a question which is sometimes asked, in which he says you are going from A to B on this particular track, and this is the distance. This is your true airspeed, 330. And he says wind velocity up to CP is this wind velocity, and thereafter this is the wind velocity. Calculate DCP and time to CP. For home ground speed, use this wind velocity, because up to the critical point, this is the ground speed. So x divided by h calculated with this wind velocity should be equal to d minus x calculated with the outbound ground speed, and calculate outbound ground speed with this wind velocity, dH over O plus h. Again, when you are calculating the time to the critical point, use the value of ground speed outbound. Don't use the same outbound which you found out just now. Use fresh outbound ground speed using this wind velocity up to critical point. So you got the distance of the critical point. With this ground speed, calculate wind velocity, find out ground speed outbound, and you will have your answer. Interesting question. And application, or draw a small sketch and write down these two wind velocities. Then you see, if I go back, this wind velocity, go outbound this velocity, and while going to the critical point, this is the wind velocity. Outbound ground speed will be here. Next one is another interesting question, application of what you learned. He says that DCP in case of engine failure is this. Calculate the values of O and H on reduced power, and then calculate the DCP on reduced power is given to you. O and H is known to you. Calculate the total distance. D is not known to you now. And DCP X is given to you. After you calculate this distance to critical point, now find out the time to the critical point. And don't forget, now I will have to use the normal true airspeed. Okay, normal true airspeed to find the ground speed outbound. With that ground speed, calculate your time to the critical point. And these are the questions. And here are your answers. Look at them only if you have finished your questions. The worst thing person can do is cheat himself. Don't do it. Question number 1, 2, 3, 4, and 5. So this is where I will stop, and we will come back to another important aspect that is called point of no return or point of safe return in subsequent lessons. And similarly, we will learn point of no return or point of safe return with normal power and the reduced power. Now, as usual, I'll remind you, please like and subscribe to the channel. If you are enjoying the videos over here, and more the number of likes and subscription, okay, it will encourage me to put more and more lessons for you. So if you are liking it, then please go ahead and press the bell icon, okay, so that you get the notifications. Bye-bye. Good luck. Happy landings. Continue with your flying and the ground subject seriously, and all the best. And we'll see you soon. SK Booty here, stopping here for the day. Okay.